Hi everyone. Okay, welcome to another Coding Bytes. In this one, we're going to speak through really the TwinCAT side of the PlayStation 5 project. Now, there's a couple of there's a shout out that I want to do first, which is just from Flock, who made Pi DualSense. This is the Python library that I've used to do all the Python side. So there was some .NET versions. I thought I'd stick with Python because the last Xbox was done in Python as well, just so too many moving pieces didn't change. But yeah, no, thank you very much for this. This allowed this project to continue as it was. It's MIT license, so again, you can all feel free to use this. Brilliant. There we go. So what we've got, two halves to this project. Like I say, they've got the Python side, which is what's doing all the communication with the controller itself. So, and actually the we'll get into it, but there's also another library that gets used in Python, which is all part. It's described in this Pi DualSense anyway. I'm probably going to use that as a final video to this series, funny enough. So I'm going to do the Python at the end. That'll just be its own thing because there's a little bit just to spin up the Python side. Obviously, for those of you who know Python already, it'll be fairly easy to get this up and running. But otherwise, I will do like almost a getting started guide on this. And we'll add to the README file. So, but like I say, we've got the Python side that speaks to the controller. The controller speaks to TwinCAT via ADS, this ADS library that's available, and then the TwinCAT side obviously takes care of, well, all it does is it holds a GVL, which holds all the symbols. Those symbols themselves, we move a few things around just into a structure, just to make some of the graphs slightly easier to show. But otherwise, we then push it up into TwinCAT Hmi. We'll see that TwinCAT Hmi, we've used the project generator. So the layout, that was all automatic. The other thing we've used is TwinCAT Scope. So awesome, really, really, really nice because you just set up a scope project, drop it into your TwinCAT Hmi project and it works. And you get a very high resolution scope. And other things we've done is we've used some third-party libraries and tools just to allow us to bring in a 3D model. So we'll quickly speak through all of those as well. So getting started, obviously read through. This is going to change. There'll be some amendments. There's going to be bits and pieces. I'm going to improve the installation guide, how this whole thing comes together. So hopefully you can just read this rather than just following the videos. But yeah, primarily clone it. And in the source, what you're going to do is you're going to find the TwinCAT file and the Python files. So TwinCAT all the way for the time being. Head off, download that, open that up into TwinCAT. What you're going to see, so just opening up the main project, we've just got main over here. There's not really much code. Because like I say, when you're talking ADS has the ability to talk straight in onto the symbols. So if I've got a global variable list, if I've got any variables sitting anywhere really, as long as they've not been marked as hidden, ADS can see them and write to them. So, and read from them. That's just one of those things. It's kind of all-knowing. It can get everywhere. You have to explicitly say, as a programmer, if you don't want your variables to be seen or accessed via ADS. Right, so we've got a GVL that's holding the whole thing together. And what that's got primarily is a controller structure. So this is feedback from the controller. So again, just ints and balls primarily. You can see everything here. So we've got the trackpad touch, the thumb buttons, the X, the Ys, triangle, circle, square. We've got controller command. This is something that I fill out and I don't send it via the PLC. So like I say, the PLC is just holding these variables and it's the Python script at the other end that actually writes the controller to this structure, which is held in controller here. And it reads back from controller command. So all I have to do from a TwinCAT Hmi point of view or anything like this, I just have to make the variables available in here. The Python script automatically grabs them and then checks to see if there's differences, and then it applies the differences to the controller itself. The other thing I do is I'm using enumerations for some of the commands because it may as well. That's completely fine. There's enumerations in the Python side. And what you'll see is I've just mimicked it's almost copy paste. I've taken the enumerations from the Python and brought it over into TwinCAT. What's nice as well is enumerations work really well with TwinCAT Hmi. So it naturally finds the enumerations, and when we write values and read values, it works with enumerations too. Another thing as well I just wanted to show you, just in this one here, is in enumerations, you can actually do logic in your enumerations, in a lot of constants too. So I've seen a lot of customers where they might do some mathematics on what they want their constant to be. That's no problem. So the compiler itself actually, as it's making the constant, will actually perform operations for you. So in this one here, the values of this enumeration is actually being built up by ORing some numbers together. Okay, right, so I think that's about it. So really, that is all from the PLC. The only other thing that you'll see in main is I've got a structure for point, and what that is, it's just a multi-dimensional array of point, and that's just one of those things you have to set up when we're working with a line graph in TwinCAT Hmi. It just has to be in a certain structure. I could have done that in the JavaScript. I didn't, because quite often it will be this way that people will use it. So I thought, well, there we go. Take the value of these and just put them in the structure in the right way, the array, multi-dimensional array structure, just so I can feed this data straight into the graph. Nothing else needs to be done. Okay, right, well that completes the PLC. So the PLC itself, you just set it up and running, activate the configuration. Obviously you can have some licenses that you're going to need to install. Well, set up your 7-day trial licenses. Just to show you that one as well. Oops, sorry, missed my license button. Which it's not allowing me to do because unfortunately I get a slight issue with my mouse sometimes when I'm recording. There we go. So the licenses I'm using in this instance are PLC, TwinCAT Hmi server, because I've got HMI, and also as well TwinCAT Hmi server scope. This is great. So just drops the scope straight into your HMI. Anyway, onwards and upwards. Let's move that out of the way, shut that down. So once that's activated, up and running, obviously you've got your 7-day trial licenses all up and running, you're going to be able to run this project and see it actually on your PC. The next thing we've got here, let me just go through. So like I said, I use the project generator of TwinCAT HMI, and the reason I use that is because I like the way it looks. What it brings to the table is it sets up all these top bars, the sidebars, navigation. It asks you if you've got dynamic screen sizes, which I didn't do in this one because I wanted to keep it static. But yeah, it can be very dynamic. It can work out how it changes size. It sets a lot of this stuff up for you already. So I started with that. Use a project generator. Check it out. It's a good feature. It's a new feature, and it makes a nice looking screen. It actually it brings in as well a dark theme too, which the user can swap between. I actually removed the dark theme only because the image of the controller didn't look very nice with it, so I just removed it. It was just one of those things. I didn't want to maintain it. So, but yeah, you get access to different themes as well, which is, again, we'll expand upon. So the first thing I'm going to speak about is how this part come together. So obviously desktop view, it allowed us to make pages. It made these for me as well in this project generator too. So the first one I'm going to go on to is this controller interactions content. Now this one here, just again exactly the same way as what I did with the Xbox controller project. All of these things here, all I'm doing is I'm looking for a variable to change, and then as that variable changes, if it changes to true, I apply class to this. I think this is just a label that I'm using on this one. I apply a class to the label, and that class holds the color information, or it could hold the font information I want to use. So instead of hard coding just loads of colors everywhere, what I'm actually doing is saying, hey, on symbol change, can you just add a class to it? And the class I'm using is, I think, on label active. But anyway, let's just see what that looks like. So just opening up properties, you're going to see the first one is I'm using a custom event. So custom events, instead of things like on press, mouse click, that this and the other, what I'm saying is, no, I want a custom event on a symbol changing. Now, it doesn't matter what it's changing to, as long as it's changing. That will trigger this event to be fired. So, and if we look in this event, what I'm doing is just doing a straight if statement off the back of it. I'm ifing that one variable, and I'm saying if it equals to true, then write to symbol. This is the text box itself, and I'll show you the one that I've actually used, class names. So what I'm doing is I'm writing the class name of isActiveLabel into the class names property. Just the same as if it's false, it's going to write that is not active label into its class name. So and what that does, what that has the effect of, is if I look in themes and the base theme, we can see here that I've made that is active label. And what happens is it brings over a background color. It says, hey, there's background color. It's going to be this light green in this instance. And likewise with the is not active label, it's going to be the gray. This is the ideal place. I see a lot of people hard code colors into status changes or something, or even just basic things. So maybe a button is a confirmation button, and they hard code all of the colors and styling, and which is all right, but unfortunately that's not themable because we support multi themes. So we have the ability to say, hey, swap to a different theme now at using time at runtime. So while the user's using it. And if you've coded using classes, because you don't have to add and remove classes on events, you can actually set classes up just on any of your buttons. Now it doesn't matter. Just go into properties. There's a property for class name, and you can just assign it. It's not actually going to show me something at the moment. Let's just make sure something's. Oh, sorry, I'm on desktop view at the moment. There's a class name property, so you could say, well, actually, for all my confirmation buttons, I'll add the class name of confirmation button, and then the confirmation button styling is looked after by the theme instead of hard coding it in here. Sorry, tends to turn into a little bit of a sort of a tuition video as well. So if you've watched any of my other Coding Bytes videos, I tend to throw some information out there just in case. Oh, it's all about learning at the end of the day. So so highly recommend themes. Lots of information on themes. Definitely use it. Use class names. Don't hard code styles. That's what I'm going to take away from that, which is exactly that. Because maybe we want to change all of the buttons now to turn purple when we press them. I just have to change one theme setting, and they all occur. So that's how these parts work. We've got the linear. Let me just go back onto the right page so it's a bit more clickable. I've got linear gauges here showing me analog values, and again, those are really easy to set up. You just drag them on. You can actually see I have hard coded a progress foreground. Could really have done that in a class as well. So you tell it what variable you want to look at, the minimum and maximum values. You can change it around to say what tick, mini ticks, and like the maximum ticks and the minimum tick sizes, these things here. Set them up, start them as you need to, and away they go. They just work on demand. This part here, so this one is my line graph. So, and you can actually read up there, it's upside down. I've done that on purpose. It was more to show you transitions, because the XY coordinates I get from the controller are inversed. So they're kind of, I think games coordinates compared to screen coordinates are always inversed. There's something along those lines. So instead of just inversing the values and then putting them in, doing it in the PLC, which would have been fine, what I did instead was I just threw the raw values straight into the graph. And then what we've got is just down in layout, transform. I can apply a transform to this. I'm just going to move that so you can see it. And the scale, I've actually inverse scaled it. So I just scaled it in the Y direction by -1, which actually flips it over. So I thought, there we go. There's a way of showing you scale, just a one button press, and it now works the right way. Just bear that in mind though, that if you were to show labels, or if you were to show any information on that graph at all, it's going to be upside down. So, but anyway, there we go. Next, oh, the other one as well, line graph data. So it takes that touch data. That's the type. That's the type that's in the PLC. I was able to put that data straight in. We've got a couple of line graph definitions in here as well. Let me just drag that on so you can see them. And all I'm doing there is just stipulating two separate colors for the two lots of data. And I'm pushing their point dot radius right up to 10. I'm making blue and red, and their line width is 0. So I'm using a line graph to do this, but it has the effect of a single point of a line, no other lines connected to it, and the point is really big. So it worked fine. Otherwise, you could have done it another way. I mean, there's nothing to stop you using canvases, other JavaScript components, but this is how I did it here. Okay, next, is there anything? These ones here. So these ones are user controls, just in case I have more of them, because obviously the minute I've got two lots of things that are more complex than just swapping out variables, I've made them into a user control just to make that a little bit easier. So these things here, all I'm doing is I'm passing in the X and Y values taken from the stick. So I get the two values for horizontal and vertical movement. If we just look inside them, I'm just playing a little trick of Let me just open up the folder and the joysticks. Nice little trick this. So it looks better. It's more. It looks effective for the amount of coding that's inside it. So this one here, all I'm doing is stipulating a size and its current position. I'm doing the transform again, similar to that scaling. But this time I scale and I'm doing a translate, and I'm just doing a little bit of scaling on it, but I'm changing its X and its Y position based on the raw value coming in. So so I've got a maximum, well, I get positive and negative 128 from the joysticks. So I'm scaling them. I'm just times it by 30 because that puts me back into pixels on here. And that's it. I'm just translating their position based on the raw value. So I'm just moving that circle backwards and forwards. And it has the effect of looking like I'm moving the sticks around. The other thing as well I've got is I'm checking the variable that comes in, just so that when they press it, I also turn it green, the same as the labels. So that's that. D-pad control, I won't show you too much because the D-pad control itself was just rounded rectangles that I'm just changing the background colour. And that's it. So that's the controller interaction done. Fairly simple with almost minimal coding. You've got quite a nice looking display. The next thing I'm going to do is just show you the motion feedback. So motion feedback has got two elements. The first one we will look at is the 3D model. So the 3D model itself, what I've done with that is I'm using a HTML host, which means I'm allowed to just drag in other HTML code as much as I like, and I can utilize other people's libraries and all that good stuff. So let's just have a quick look at the code. I can swap it into code view and say run through this somewhat. I'm using a thing called model viewer. It's actually this one here. So model viewer, let me just call up on here, model viewer. So again, this is available for everyone to use. So I'm pretty sure, from what I remember, it's the MIT license as well. I always check beforehand just to make sure I am able to use these free of charge in any of this kit. So so again, it's just it's a model viewer that allows me to interact with models. I believe, I'm going to say it, I think it's part of the Google team that are putting this together. But anyway, okay, it was good. I did a little bit of research on model viewers. There's a lot out there, a lot of them open source too. You just have to have the right type of model that you can import. So so this is the code that I'm using, and you can see here this is how you import the JavaScript that you're going to use, and then they start giving you some really, I mean, it's really well done. They've got examples on how this well, everything, even supports augmented reality. Look at that, staging cameras, lighting. So, and really it was a case of just going through, checking to see what examples they gave me and seeing how I can interact with it. Now, swapping back, we can just see, so that is the model viewer. It's using the model here, GLTF file. So you'll actually see that in here, the controller. It's a controller that I've put together. It was constructed out of, again, open source parts just out there. So so what I've done, I actually took it through a few different steps. So originally going from a 3D model, which was exported as just an object. The object itself, we had to get it into this in this GLTF file format. Now I found a good site called 3JS, and 3JS itself has got an editor, and the editor has got some fantastic import and export facilities. So we have the ability to import, and then we have the ability to export into a huge amount. So again, this is what I used to do, because I had to push it all the way through to the point where this model was usable in the in this library, this model viewer. So, and it's actually this one that I've used. And plus as well, it allowed me just to have a look around the model. I can't really say too much in this one as well. Model viewer as well, from what I remember, there's also a way of viewing it in model viewer too. But anyway, 3JS allowed me to export it in the right format. So that's what I use for that. This thing here as well, I've just got a function that scales the gyro, because this thing here, I'm taking raw values, I'm turning them into just angles, so to be able to move them. And this thing, let's just have a little look. I set up the camera orbit to start with. So I'm using this document query selector to start with there. So what that's saying is, hey, go off and find the thing that is controller model, which is this one. I've got a previously declared function I can use just later. That's just ready to go. Once I've got it, I can call camera orbit, which is just one of the APIs that they give us, and that's my starting angle. The next thing I do here, so this bit of code here says create a command which is going to pull up the PLC global controller symbol. Now that is the entire thing. I'm actually pulling out the entire, well, I'm not pulling anything at that point. I'm saying that's the symbol I want to do something with, and it's the entire symbol. I'm setting up a subscription. Now I could have actually set up a subscription to like a subpart of this, but for the time being, or subscribe to multiple in one. For just ease, I just subscribe to the entire symbol, the entire structure changing. So once I've made this little command here, I can then call our TwinCAT Hmi API. And we've got a few different commands on this, and one of them being tchmi.server.subscribe. You pass in the command that you want it to do, which holds the symbol, how often you want it to subscribe, or I think it's actually the maximum, it's the minimum delay between updates, because if the variable is changing even faster than this value, then it will drop it. So if it's changing every 1 millisecond, we won't get every 1 millisecond update. So it's going to be at least maximum of 100 milliseconds update. And when the variable changes, it's going to call this function right here. It's going to pass in the variables via this data. And again, I've not got too much error handling in this at the moment, just because, yeah, rather than padding it out with error handling. So we're just saying that if there's no error, then process this part here. We take this apart. We actually see this in TwinCAT Hmi documentation, that we can say that the data has a response. The response has a command being, this is the first command, so it's the 0 command. We ask it to read the value, and it's the gyro roll and gyro pitch that directly relates to what the structure was called in the first place. So when we look inside the DUT for the controller, we've got gyro roll and gyro pitch. There we go. Okay, let's just go back into that so we can see it. So once that's done, I scale it, put it back into, so from, I think it's, yeah, positive 9,000 to negative 9,000. I put that into degrees, positive and negative degrees. And then finally, I actually forced the model to orientate itself. Originally, I started with changing the camera angles, but you get some crazy things with the camera angles. It's a lot easier modifying the model's orientation than it is to pan and tilt a camera over. So I'm sure you can do it both directions, but yeah, in the end, I've just said, hey, model viewer.orientation. And this is just a syntax for allowing us to push variables into a string, funny enough. So 0 degrees, but with the value of roll in degrees and the value of pitch in degrees. And then model viewer takes care of that, does all the orientation for us. So every time we get an update on that subscribed variables changing, so as I'm moving the controller around, all it's doing is just saying, hey, model viewer, please just keep changing the orientation. There we go. And if I don't touch it, it doesn't do anything. It just stays as it is. So that's it. That's the 3D model viewer. So there really wasn't much to this one. Other things that I just want to, we'll speak to you about. Let's just make sure I'm not going to miss anything. No, so far so good. Yeah, IRO is going to be in a minute. Right, so the next thing I'm going to do is just talk you through the scope. So adding the scope is incredibly easier as well. So if you're going to bring the scope view in, scope view is an amazing ability to add scope into your TwinCAT Hmi with almost, well, with zero coding. It's just a little bit of configuration, that's all. So with the scope, all we do is we just right click, say that we're going to add a new scope. We can either use the wizard or we can just set the scope up ourselves. And what we're going to do, all I did was set up a scope that looked how I wanted it to look. I dragged in the variables I wanted to measure, which was the X, Y, and Z. Well, it's not X, Y, and Z. I actually renamed the variables from the PLC program. Drag those variables in from the target and set up the colors, if it was going to auto scale, that type of thing, and then saved it. So once this thing was configured as a scope, and again, let us know if you need any more information on scope. There's lots of information out there. Infosys is awesome. We're taking you through it. But again, if you need a Coding Bytes video on scope, that shouldn't be an issue. So you set your scope up, and the scope itself is normally you just hit record and away it goes. So once this thing has been set up as a scope, there's only really a couple of steps to then get this into the TwinCAT HMI. The first thing you need to do is in references, we're just going to manage our NuGet packages. So because everything's really a package nowadays when it comes to TwinCAT HMI, that's how we bring functionality in. And in the installed, well, you'd be doing browse, make sure it's on HMI official, and you're looking for, just make sure you get the right one, because one of them brings in dependency, brings in scope. If you do this one, scope control, which is the thing that we use, install that and it'll automatically install the scope for you as well. So if you do this one, it doesn't install the second one, and then you have to go and do the second one as well. So you may as well just do scope control and it'll bring it in. So bring that in. That's the first things first. The next thing that we do, let me just go back onto that motion feedback. And once that's done, in Toolbox, we then get access to something new, which will be scope control. Drag that on. So once that's then done, we've got access to properties. Let's just make sure this scope config. And when we open up scope config itself, what we're able to do is import a scope config. We have to give it a name first, and then we browse for the solution. And what it'll do is it'll actually find any available scopes that you wish to bring in. And that's it. Select the scope that you want, and then when you go live with this, it naturally brings the scope up. You can tell it to auto start as well, which is ideal. So, and that's it. That's how we brought in the scope for this application. So really no major headache in getting a scope in at all. Yeah, there's scope. Last ones. So again, tend to drag out a little bit these videos. So, but this is why we're going to do the Python next. The last part, settings. There's only a few things here which are out of the ordinary, and that's going to be this color, the color picker. So we'll talk about this one. All of the rest of these things, they're just push buttons. And again, I'm using exactly the same trick. When you look at the properties, so the properties here on the events, I check to see if a variable changes, which is the variable itself that I'm writing to. So on change, I do something. When I look inside here, so this player LED, I check to see if the variable is player LED brightness. So this one actually, because this is an enumeration, it can be any of these enumerations. So all of those actually, so everything on that line there, if I go off player LED light bar or both, that's affecting one symbol, and its value is of player LED. So so you can see here that TwinCAT HMI is happy to use enumerations. I didn't need to code any of that. The fact that I had a symbol of that enumeration, it automatically gets imported into TwinCAT HMI, and we can work with it there. So if that variable, which is LED options, is player LED brightness, then again I play the trick with the class names. So, and I did an isActive button instead because it has slightly different properties. So isActive button or is not active button. Actually, I didn't do that on this one. I just emptied it, cleared it out. So the buttons themselves return back to their standard state. Okay, the other thing I did is on pressed is I set their state. So write to symbol, and again, is that options, I write into it player LED brightness. So, and again, it knows the enumerations up front. So this is one of the nice things with enumerations to TwinCAT HMI is it learns them and it makes them available as values. It even knows they are the values that should be there. Right, so that's all of those. These ones are user controls again, just to save me some coding, but again, follow the same pattern as the standard user control. These themselves, toggle switches, again, you just attach them to the symbol and they just naturally do their job. These ones, there was a slight change I needed to make on these ones. So these are linear gauges, which I tick to say that they're editable. So the same linear gauges which are on the triggers, it's just I've given them an editable tick, which means I get the value here. And this value, I'm reading the value in. Now, normally, if you were using reals, because these work as reals or doubles, as they class them as in JavaScript, if you needed it to write back, you double click and you say there are two-way binding, and the two-way binding takes effect on change. Now, I couldn't do that in this instance because the structure I was passing about, they were integers. So the minute I tried to do that, as I move them around, it says, I'm sorry, you can't do that because I expected an integer and I received a double. So I needed to do a little bit of change. This is kind of old school as well. So sort of pre-12, version 10, we had to do this a lot. So this one here, it doesn't matter. So because I just hard code it myself instead. So anything you can't do just natively with the controls we've got, you can just go coding yourself. It doesn't matter. So all I said instead was on user interaction finished, call this event. And this event does this little bit of JavaScript. So it took the original, so the haptic feedback left value off of the gauge itself, take the gauge's value and put it into that variable. But what I'm going to do is pass it through a little function first called parseInt with 10, which means it strips off all the back end. It just turns it just straight into an integer value. No longer a double. That's a JavaScript function. And again, I can just write it straight in here. And that JavaScript function gets called, turns it into an integer, and then passes it to the variable instead. So that's why this lives here. And last but not least, this is the last thing I'm going to cover in this video before we then get into the Python. This one here, this color picker. Again, I need to add this to the list of shout outs. So with this one was done slightly different. So this one I've actually imported. So iro.js, it's a little color picker and you can bring it around, move it around. Really, really nice that. So, and plus as well, they gave really excellent examples of how to use it. The demos, they even dropped you into like a little area where you can configure it yourself and make it what you want it to be. So really it was a case of once that was done, I just pulled that code out, dropped it into a HTML container, and that was it. Hooked it into the variables, that type of thing. So I'll show you that code next, but this is where this again will be linked on the repo too. So let's just move that out of the way, swap onto code view, and we can see this one here. So the color picker itself. So first off, this was one of the ones, instead of referring it directly, so the other one you need an internet connection to be able to use the 3D model. This one I showed in the example of how you just take the JavaScript file and just drag it straight into the imports and it becomes available to you. So at that point there, this was taken from one of their examples, very, very slightly changed, just so it worked with hue. So again, just following the documentation, I just converted that to hue. And then what they had is they gave us a load of events, and one of the events they gave us was input end. So it allowed us to hook in a function that gets called when the person finishes sliding. Great, that's exactly it. They pass us color, and color is an object with R and G and B in there. Well, actually, it's not. It's color, and it has a property of RGB, and that has a property of R, G, and B. You've also got HVL. You've got loads of different things. So they've really made it very easy for you to use. So what I'm doing in that instance, every time I get an input end, so someone's finished selecting the color, I call again from our TwinCAT Hmi API. I'm calling TCHMI server write symbol. I'm actually passing in an array of symbols that I want to write, because that's fine. You're allowed to do more than one at once. So I'm passing in the symbols for red LED, green LED, and blue LED, and then I'm taking apart and saying, here's an array of the values themselves, color.rgb.r.g.b. I don't actually have anything in my function there. So this function, the last argument of write symbol, that's a callback function that we get response from the server to say, did it do it well? What was the response codes? I've not actually implemented anything there. I should react to an error. Maybe I push it up into the event log, that type of thing. But this is more just to show you some things. It's not a true guide into best practice programming all the way through. Okay. And I think that's about it. So yes, we've covered bringing in third-party controls, which is the 3D model and the color picker. We've got high resolution scoping of variables of the accelerometer. Now that's running at the PLC's rate as well. So that is being traced per PLC cycle, which is 10 milliseconds at the moment. We used the project generator to actually make the layout and kick us off in the right direction with this, and that's it. TwinCAT Hmi doing all the heavy lifting. It brings all of these packages together, NuGet packages, packages from out in the web. Yeah, easy to use, nice to use. Run it on a 7-day trial license, which is great. Helps you develop, free for developing. What could be better than that, eh? Right, so that completes this video. I hope you enjoyed it. And the next part of the video will be installing the Python, getting the Python up and running, and then just a little walkthrough of it actually working. Okay, see you in the next video.